So we're going to look at one more application problem of right triangle trigonometry. The following says that we have two oceanfront homes that are located 8 miles apart on a straight stretch of beach. Each distance of 1 mile from the paved road and parallels with the ocean. Sally can jog 8 miles per hour along the paved road, but she can only jog 3 miles per hour in the sand on the beach. Because there's a river that flows between the two houses, it's necessary to jog on the sand to the road, continue on the road, and then jog on the sand to get to one house to the other. So looking at the following picture, illustration below, we want to express the time t to get from one house to the other as a function of the angle theta shown in our illustration below. Okay, so we want to figure out how fast. We know that distance is equal to rate times time. And we're trying to find how fast. And so we know that time then is equal to the distance run all over how fast she's running. And so it depends on which piece that we're looking at. And so let's look at this piece right here. So this is the hypotenuse, and she will be running on the hypotenuse of those triangles. We are trying to figure out what that distance is. So maybe let's just call that C. We're given that from the house down to the road, this length here is 1. And so if we look at theta, we're looking at theta, we have opposite of theta and we have hypotenuse. And so opposite and hypotenuse tells us that we're going to use sine. So let's rewrite this. So we know that sine theta, this is equal to opposite, which is 1, all over the hypotenuse, which is C. We're trying to figure out what C is. And so we can find out what C is if we multiply both sides by C. We get C times sine theta is equal to 1. So C is equal to 1 divided by sine theta. And so that is our distance from running on the sand. And running on the sand, it tells us that she can only run 3 miles per hour. And so C is our distance. So our time on the sand this is equal to distance, which is 1 over sine theta, all divided by the time, which is 3 miles per hour. So the time on the sand, and that's just one of the times. This we can think is invert multiply, so 1 all over 3 sine theta. But we have 2 of those pieces, this piece plus this piece. So we're going to have 2 times this is actually the total time on the sand. Then we have this other piece in here, which is this. Well, we know that that whole distance, that horizontal distance is 8. So if we could figure out what this x is in here, that's the same thing as x is over here. So we could look at that distance in here is 8 minus 2 times x. So let's figure out what x is. And so looking from our angle theta, we can figure out what this length x is. And so that is the opposite side of theta. And I'm sorry, that's the adjacent side of theta. And we know the opposite. And so that's telling us to use tangent. And so we have tangent theta. This is equal to opposite, which is 1, all over adjacent side, which is x. So getting x by itself, we would multiply both sides by x. We get x tangent theta equals 1, or x is equal to 1 divided by tangent theta. And so this distance in here, we're looking at the rate that she's running in that distance. So that distance in there was 8 minus 2 of those. So that distance was equal to 8 minus 2 times x, but we just found x to be 1 over tangent theta. So that is just the distance. And so to look at the time, we're going to look at the distance divided by the rate that she can travel. Maybe let's I was going to get this as a single fraction. So getting a common denominator, multiplying tangent theta divided by tangent theta to 8, we get 8 tangent theta minus 2 all over tangent theta. And so the time on the road, let's call that R. So time on the road, this is equal to the distance, which we just said was 8 tangent theta minus 2 all over tangent theta, all over the time. And the time, or the rate, sorry, the rate, and the rate that she can go on the road was 8 miles per hour. So divided by 8. Think of it as 8 over 1. Now let's do our invert multiplying. And so we have the time on the road. This is equal to 8 tangent theta minus 2 all over 8 tangent theta. So the total time is equal to the time on the sand, which we found to be 1 over 3 sine theta, but there's 2 of those pieces. So we said multiply that by 2. So the time on the, sorry, that's the sand. The time on the sand is 2 all over 3 sine theta plus the time on the road, which we just found to be 8 tangent theta minus 2 all over 8 tangent theta. So this is the total time t to get from one house to the other, going on the sand, then going on the road, and then back up on the sand again. And then the next part of the question, and we're out of time, so I'm going to let you guys do that. The next part of the question is figure out what the time it would take given that theta is a certain angle. So 30 degrees, 45 degrees, or 60 degrees. Well, we already have the formula there. So all we have to do is go in there and plug in those values for theta.